Good morning, everyone, and sorry about the delay. We had slight hiccups with the live stream, but they are now all solved, so we are ready to get started. I'm Matthias. I hope you're having a wonderful time at I/O. I'm colleagues with Yuna and Bramos, who are on stage just right before me, and together with you all, I want to do a deep dive on one of the announcements we made on the developer keynote stage yesterday. Chrome DevTools for agents. In the next 20 minutes, I'll cover what it is, what it's useful for, and how you can get started yourself. So first, for those who are new to this, or new to the web track at Google I/O, welcome. This here on the screen is DevTools. It's what opens when you right-click in Chrome and then select Inspect. DevTools is what you'll trial and error around in to find the right combination of CSS properties to make your things look as splendid as in Yuna's and Brahma's talk. In September last year, the same DevTools you know and love got a new UI surface, additional to what you'll get when you right-click and inspect. Chrome DevTools for agents. Let's dive in. We're going to start with a general overview of what Chrome DevTools for agents is, where it lives, how it relates to your other tools, and how your agent can use it. Then we are going to look at the foundational technologies that enable the capabilities of DevTools for agents. Having a basic understanding of this will be the foundation to understand the actual capabilities and use cases. Before we look into the various configuration options, and finally, how you can get started. But first, we're going to do some time travel. I want to take you on a virtual trip back in time to the beginning of your career. Whenever this was. Maybe it's been a couple of months, 3 years, or decades ago. That doesn't really matter. Just try to think how it was as an absolute web developer beginner. For me, this was in 2014. This was me back then. That's my first corporate profile picture on the day I joined as an apprentice web developer to learn web development. I was part of a team of around 20 other engineers who were taking turns in teaching me web development over the course of 2 years. The one thing all my colleagues had in common, they used DevTools to show and demonstrate things to me. For example, I learned that the static HTML from my code editor turns into a dynamic, living thing called DOM by clicking through the Elements panel. Later in my career, I learned about web performance by running Lighthouse audits over and over again and just blindly following the advice it gave me until the scores turned green, without really understanding the background. So for me, DevTools enabled a closed feedback loop during my learning journey. Through DevTools, I could inspect the live page I was working on, fiddle with it, try and break things, and debug issues. And this has been true for me, just as millions of other developers out there, including you, before and after us. But there are a few developers who learned web development without ever touching DevTools. They are over 3 years into their career now, and they are doing a fairly decent job, I would say, but they never touch DevTools. I'm talking about coding agents, obviously. We think they are missing out and could do more if we give them the right tools. We believe that giving your coding agent access to DevTools through DevTools for agents enables the same closed feedback loop for them you benefited from your whole career. Let's look at a debugging example. The way you would manually handle it, even with AI in the game. This is a sign-up form using a company's internal auth provider called Showtime. It's not publicly documented, so no AI model knows about it. When I try to register and it fails, I only get cryptic error messages like app error 1003. Your out-of-the-box coding agent runs into a bunch of dead ends debugging an issue like this. First of all, it would rely on you to manually surface the issue. But then also, if you actually surface the issue already and you prompt, please fix app error 1003 in sign-up form TSX when trying to sign up with your coding agent, it can't do much, really. It will search for app error 1003 across the code base and then just spiral. If it got lucky, after some digging, my coding agent might find this lousy to-do comment I left for it. To do, handle specific error code. Excellent, right? Little does my coding agent know that this solution is actually not too far. Any wild guesses where it is? Is it A, in the training data of the model? Or is it B, in the source code? Or is it C, in the runtime data? After you listen to my heartwarming story of how I learned web development, you will know it's C. The solution is in the runtime data. Let me show you where. When I'm submitting the sign-up form, a request is being sent to an API. And all network requests sent from a page are surfaced in DevTools. It's the same here. So when we look in the network panel in DevTools, inspect the failing request, and look at the response, we see there is actually an additional message that we can use to give the user more information. And not only can we use those network requests, but our coding agent as well. Giving your coding agent access to this information through DevTools enables this closed feedback loop I mentioned before. But let's see if that's true by giving it a test run. Before we can do that, though, we need to tweak our prompt just so slightly. Instead of asking our agent to look at specific files, we ask it to look at the runtime. As DevTools for Agents has access to source maps, it will be able to guide your coding agent to the right file anyway. So we are going with go to localhost, sign up, debug and fix the error when signing up with test and 1234. Using this prompt with my coding agent, anti-gravity in this case, and DevTools for Agents enabled, we'll start a full end-to-end fixing flow. The agent will open the page in a real Chrome instance, try to log in, capture any console logs or network requests, and combine all the pointers to actually fix the code. That's the power of DevTools for Agents. All right, so after you've seen this first example of what Chrome DevTools for Agents can do, let's briefly look into the foundation of it all, as this will help you get a better understanding of the use cases we'll explore in just a minute. While DevTools for Agents is new, it's actually built on a pretty solid and long-standing foundation. Using tools the same team has been maintaining for years: Chrome for testing and Puppeteer. But let's break it down. At its core, DevTools for Agents is an NPM package that you can install on any machine that has a recent Node.js version. This is what your coding agent is using. May it be anti-gravity, Gemini CLI, or whatever you prefer. Your agent might either use it through the MCP server or the CLI, which both ship as part of the same NPM package. The CLI enables your coding agent to script against DevTools for Agents, which can be more token efficient compared to using it through the MCP server. The third and last key thing that brings it all together is a set of skills which teach your coding agent how and when to use Chrome DevTools for Agents. For now, Chrome DevTools for Agents ships with a total of 6 skills, which can be roughly put in 2 categories. The troubleshooting and the Chrome DevTools and Chrome DevTools CLI skills help your coding agent to understand key capabilities, concepts, and general usage. The accessibility debugging, the memory leak debugging, and optimize LCP skills include expert knowledge in that specific area, which makes your coding agent act as the same expert. As part of modern web guidance, you might have heard about in the keynote yesterday or in Phil's talk, this skill set will expand over the coming months to help your agent debug the web's newest features. To learn more about modern web guidance, find Phil's session, Unlock Modern Web Capabilities in Your AI Coding Workflows from yesterday on YouTube to learn more. Now, from skills, back to the overall architecture. DevTools for Agents is an NPM package with skills, an MCP server, and a CLI. The thing we haven't looked into yet, how does any of this talk to Chrome? Through Puppeteer, the same library from the Chrome tooling team that you might have used in the past to run tests, automate an annoying workflow, or scrape something. While this layer is mostly invisible when you're using DevTools for Agents, it's helpful to know this, because ultimately, it's Puppeteer giving DevTools for Agents its capabilities. And before we get into those, knowing Puppeteer is the layer in between might also help you better assess security and when to use Chrome DevTools for Agents. For example, under one of our recent YouTube tutorials, someone recently asked, does DevTools for Agents have access to my passwords saved in Chrome's password manager? The clear answer is no. DevTools for Agents does not have access to passwords saved in Chrome's password manager. It is not using Chrome like you are as a human user. It's only using a vetted and tested set of tools through Puppeteer. And Puppeteer doesn't expose that as a capability. But also, DevTools for Agents uses a separate, anonymous browser profile by default. And while this largely reduces a few of the most common security risks around giving agents access to a browser, the advice to always carefully decide what you give agents access to never gets old. No matter how boring it sounds, it's critical to protect your personal data. Awesome. So now that we've fully explored how it works under the hood, let's dive into some examples of what it can actually do. As you just learned, DevTools for Agents inherits its capabilities from Puppeteer. But when you prompt in your coding agent, your agent doesn't directly use Puppeteer. Instead, we wrapped key Puppeteer capabilities in a set of distinct tools properly described, and by this, easier to consume by your coding agent. Those tools can be divided into 6 overall categories. In this section, I want to walk you through 3 different use case examples, exploring how tools from multiple categories play together to fulfill a certain user prompt. The first example is the one you've already seen, with a prompt like go to localhost, debug and fix the error when signing up with test, and 1, 2, 3, 4. We had the coding agent navigate to the page, fill in the form, and then fix the underlying error and validate its own fix, all in a real Chrome instance running on my machine. This example combines input automation, network, and navigation automation. Our partner CyberAgent has brought this use case to the next level when they set up an agent with access to DevTools for Agents and let it audit over 230 stories in Storybook across 32 components in just 1 hour of runtime. To learn more about this, find the case study on developer.chrome.com. For the next example, we are going to combine emulation tools, which allow DevTools for Agents to change the viewport size, for example, and debugging tools like taking a screenshot. Combining them enables your coding agent to do one-off bug validation. So before you manually go through a bugs verification process, let your agent work for you first. For example, if you have a report about not all navigation items being visible on all devices, you can prompt. Go to developer.chrome.com, check the same navigation items are visible on desktop, tablet, and mobile viewports. After you send, your coding agent, again, anti-gravity, will open a Chrome window and use the emulation tools to resize the viewport to desktop, tablet, and mobile, one after another. As a sign of this, in this screencast, you see the page occasionally overlap the window bounds. Then, in this example, anti-gravity took screenshots, interacted with the burger menu on mobile, and cross-checked everything before it will ultimately return the response in the screencast. The response will be something along the lines of the same 4 main navigation items are present across all 3 viewports, while the items themselves remain consistent, their placement and presentation adapt based on the device. There you see the final response. So with this prompt, I could automate a testing journey across 3 viewports and nested menus, including the interactions with them, sparing me all manual work and the back and forth to remind myself what actually happened on each viewport. Okay, let's look at one last use case, and to be honest, it's really my favorite one, because Chrome DevTools for Agents enables you to scale your expertise. For example, let's imagine you don't know much about web performance and only have a 57 points Lighthouse score. Or imagine you don't know much about accessibility or SEO. Now you could go in and ask your coding agent to improve any of the areas mentioned with a generic prompt like, improve the performance of this project. With a generic prompt like this and without DevTools for Agents, what will likely happen is that your coding agent just slowly starts burning through your token budget, reading all of your project files and only fixing random things it might find along the way. Ultimately, that wouldn't help your website performance. But with DevTools for Agents, it's flipped. With its specialized tools to run performance traces, analyze included insights, and run accessibility, best practices, SEO, and the new agentic browsing audit in Lighthouse, it can actually test for known problems instead of trying to guess them from your source code. This allows you and your coding agent to improve your websites in areas you're not inherently familiar with. For example, you can work on real performance issues by letting DevTools for Agents actually measure your current performance and then work against an actual target, and use performance insight in the trace to start where it matters. All through a prompt like, go to localhost, run a performance trace, and act on all findings. Or you can use the same pattern to improve accessibility. Instead of your coding agent and underlying model, just sprinkling in a couple of labels. Or you use the same pattern to ask your coding agent to work on SEO. While all of these examples you've just seen work with the MCP server and the CLI equally, some of them are perfect for the CLI, because the CLI can also run outside of an agent loop. This allows you to persist your agent's actions to shell scripts. Here's how it works. After you're done with your debugging flow with Chrome DevTools for Agents, just prompt. Persist your previous actions in DevTools to a well-named script file using the DevTools CLI. When you try a prompt like this, make sure that your coding agent has access to the DevTools CLI and the related skill, which teach it how to use the CLI. For the previous example, where we validated the navigation on developer.chrome.com, this, for example, could yield a script like this. It's opening the page, emulating the viewports, and taking the screenshots. The only bit that is missing here is the actual comparison of the results Antigravity has done for me in the screencast earlier. With this approach, using the scripts, that would be on you, the human, again. Okay, let's wrap up all use cases that we explored. We saw a prompt to automatically fix complex UI flows, one to scale your expertise running performance traces or Lighthouse audits, one to validate bug reports, and one to persist your prompted actions to scripts you can rerun outside of your coding agent. Use variations of those prompts in your own projects to achieve the same results you just saw on screen. To explore more use cases like this and more examples from other tool categories, learn more in our documentation on developer.chrome.com. Now, there is one last topic I want to look into with you: configuration. While DevTools for Agents works for most use cases out of the box, there are some configuration options you can use to tailor it to your own needs. To configure it, when using Chrome DevTools for Agents as an MCP server, find the file that has your MCP server's config. For Gemini CLI, this is usually a .gemini/static.json. For Claude, this might be in your project root at .mcp.json. For other agents, it is in similar locations you already know. In this file, just add a new entry to the args array with the option you want to configure. If you're using DevTools for agents through the CLI, make sure to explicitly include your desired option in the prompt. For example, through the channel configuration option, you can specify whether Chrome DevTools for agents should connect to any other Chrome channel than stable. Or you can use the configuration options to enable experimental options you're still working on, like the experimental support for screencasts through experimental screencasts. And for the MCP server user specifically, there are configuration options to turn off certain tool categories to save tokens. But there is one configuration option I want to particularly highlight, which is useful for both users of the CLI and the MCP server. It's AutoConnect. Think about AutoConnect as sharing your screen with your coding agent, because AutoConnect allows your coding agent to connect to an already running Chrome instance and pick right up where you left off. Let's look into why this is interesting. For this, we're going back to our initial example. We asked our coding agent to go to a specific page and sign in with a certain set of credentials. We did this so our coding agent could get to the same page state that we already reproduced in our running Chrome. But if I am already at the same state with the error right in front of my eyes, why should I waste mental energy just to write a prompt that gets my coding agent into the same state? Or even worse, manually copy and paste error messages from the browser console into my coding agent. This is what AutoConnect is for, and it works fairly simple. All you need to do is to go to Chrome, Inspect, select Remote Debugging in the sidebar, and then toggle the Allow Remote Debugging for this browser instance checkbox. Then make sure to use AutoConnect in your MCP JSON config, or explicitly prompt for it when using the CLI. Now, the next time you use your coding agent, it will connect to the Chrome you've just been using, and will also let you know if it has trouble connecting to it because you forgot to turn on remote debugging, for example. However, this is the right time to repeat the earlier advice. Carefully decide what you give agents access to. Because with AutoConnect, depending on what Chrome instance you're connecting to, DevTools for agents might use your personal Chrome profile rather than the anonymous default one, which puts your personal data at risk. Because technically, connected to my personal Chrome profile, a prompt like go to google.com shopping and order 999 colorful balloons has a high chance of actually succeeding and incurring unintended costs and consequences, like a lot of balloons ordered to my doorstep. Because in this example, I might already be logged into the shop site the agent ultimately decides to use, and the only thing it needs to do is click next and continue and check out all the time. So carefully consider what you prompt for when using AutoConnect with a personal profile. And with this, you really have everything to get started. You know how DevTools for agents works with the MCP server and the CLI. We explored a couple of example prompts, from bug validation to persisting DevTools actions into a reusable CLI script. And you learned how to configure DevTools for agents to your needs. On top of all this, we are happy to announce that since yesterday, DevTools for agents is available in its first stable release, version 1.0. However, my team might have shipped minor fix releases in the meantime, so let's say around about version 1. I think we're at 1.01 or something. But anyway, stable and good to use. Now it's time for you to get started. In the next few slides, I'm going to share resources for you to install DevTools for agents, learning material to set it up, and how to contribute back to it if you want to. First up, find install instructions for over 20 coding agents, more use cases, including the AutoConnect feature you heard about, and in-depth documentation through this link on developer.chrome.com. If you haven't seen enough of me today, you can also learn more about setting up DevTools for agents with a video tutorial on YouTube. Find it at Google/DTA setup. This video is also the beginning of a series of YouTube videos explaining use cases for DevTools for agents that will expand over time. If you have particular use cases in mind or want to learn more about, please find me on social and reach out with your idea. And don't forget, DevTools for Agents is a thriving open source project. If you see something that doesn't work, want to peek into feature discussions, or straight up contribute, find the project on GitHub. Now, that's it. Thanks so much for listening and spending your time here at the Chrome tent. This was a comprehensive overview of Chrome DevTools for Agents, and we can't wait for you to get started. Enjoy the rest of I/O and your lunch, and see you all soon.